Okay, so like I said in the introduction to quadratic functions, this unit, the section of the unit, is going to be about finding the zeros of a quadratic function. Now, we've talked about how zeros are the same as x-intercepts, but some equations don't have any x-intercepts. So for example, if we look at y equals x squared plus 1, right here, there's no place where it crosses the x-axis. Now we do want to still talk about zeros. Here they're actually going to be imaginary numbers. Okay, so if you've never heard of imaginary numbers before, we have this special number that we use a lowercase I, and I is actually going to be equal to the square root of -1. Okay, and the reason here for this, remember if we're finding zeros, x squared plus 1 equals 0, well, we could take the square, or we could subtract 1 from both sides. So we'd have x squared equals -1. Now, what would the solution be? We'd want to take the square root of both sides, and here we're taking a square root of a negative number, which we've never been allowed to do before. Well, now we'll kind of be able to do that with imaginary numbers. So I is equal to the square root of -1, and that means if you square both sides, I squared is equal to -1. So whenever you see I squared, you can put in a -1. Now, this leads to what we call complex numbers, and complex numbers are anything that we can write in the form of a plus bi. So we'll have a and b are real numbers, so we'll have a number plus a number times I, and b could be negative, so it might be a number minus a number times I. Okay, so we're going to start by writing some numbers in terms of I, and what this means is whenever we have a negative under the square root, we can kind of think of pulling the negative out and writing it as just an I. So here we'd have I square root of 16, and now we know what the square root of 16 is, so we could just call this 4I. Okay? 2 here we have negative times the square root of negative 121. Now, we're going to leave the negative out front alone. This negative under the square root comes out as an I. So we're going to have negative I square root of 121, and the square root of 121 is 11, so this would be negative 11I. So the negatives here don't cancel out or anything. It's just if you have a negative under the square root, you can pull that out and turn it into an I. So here we have square root of -7. Well, the negative just becomes an I out front, and then we have square root of 7, which can't be reduced anymore. So we might sometimes write this as the square root of 7I. You just have to be careful and make sure you know that the I is not under the square root. Okay, here we have negative square root of -10. Well, that would become negative, just the negative out front comes down. The negative under the square root becomes an I, and then we have square root of 10, which can't be reduced anymore. Here we have square root of -88. Well, that would be I square root of 88. And if we think about reducing the square root of 88, if we think about 88, 88 is 8 times 11, and 8 is 2 times 4, and 4 is 2 times 2. So we've got I times the square root of 2 times 2 times 2 times 11. One set of 2's can come out whenever we have a square, so this would be 2I square root 2 times 11 is 22. Okay, so here's how we can write negative square roots in terms of I. Now, another thing that we'll want to do is add or subtract complex numbers. Adding complex numbers, you're going to add the parts without an I, the A values, and you'll add the parts with an I. So it's very similar to combining like terms. So here we have 7 plus 5I. We don't really need, since we're just adding, we don't need the parentheses, 8 minus 3I. So we'll do 7 plus 8, so that'll give us 15. And then we've got 5I and a negative 3I, so 5 plus negative 3 is positive 2I. Okay, and we can just leave it like that. Now, subtracting is a little trickier because we have like a -1 here, and we'll distribute our negative. So we'll leave the first set alone, 6 minus 2I. When we distribute the negative, we have -4 minus 10I. So now combining like terms, we have 6 minus 4 is 2. Negative 2i minus 10i would be negative 12i. And that's how we subtract. Okay, same thing here. We'll distribute the negative. So we'll have 9 plus 7i minus 1 plus 5i. And then we'll combine our like terms. So we get 8 plus 12i. Okay, so you've learned how to simplify square roots that have negatives in them and turn them into an expression with I, and add and subtract complex numbers.